Okay class, in this video we're going to get some practice problems with molarity and molality. Remember, molarity is the number of moles of solute over the liters of solution, while molality is the moles of solute over kilograms of solution. So here we go. Our first problem states that if I dissolve 275 grams of glucose, which is C6H12O6, in 0.75 liters of water, then what is the molarity of the glucose solution? So first we're going to convert our grams of glucose into moles. We do this by creating our formula mass table for glucose and find that the formula mass for glucose is 174 grams per mole. Now I put my 275 grams of glucose over 1, and then I multiply it by 1 mole over 174 grams. That gives me 275 over 174, which equals 1.58 moles of glucose. Now I just plug my moles of glucose into my molarity equation, and that gets me 1.5 moles of glucose over 0.75 liters of solution. Once I plug those in and divide out, I get a 2.1 molar solution of glucose. Here's another molarity problem. Determine the molarity of a solution of 60 grams of lithium oxide in 4 liters of water. First, we go to convert our grams of solute to moles of solute using the formula mass table. Once we do our formula mass table for lithium oxide, we get that there is 30 grams in 1 mole of lithium oxide. So we write down what is known, so our 60 grams of lithium oxide over 1, and then multiply it by our 1 mole of lithium oxide over 30 grams of lithium oxide. Now, once we multiply these out, we get 60 over 30, and we divide that and we get 2 moles of lithium oxide. Now that we have our moles of lithium oxide, we can plug it into our molarity equation. So we take our 2 moles of lithium oxide and divide it by 4 liters of water. Now we get a 0.5 molar solution of lithium oxide. Okay, one more molarity problem before we go on to molality. This one we are going to actually work backwards. If I want to make a 5 liter 1.25 molar solution of sodium chloride, then how many grams of sodium chloride would I have to use? Well, we are given our molarity and the liters of solution, but we are not given the number of moles of sodium chloride. So first we're going to have to rearrange the equation for molarity so that we can get the number of moles of sodium chloride within the solution. Then we are going to have to take those moles, and using our formula mass, we're going to use that to determine the mass of the sodium chloride. So to rearrange the equation for molarity, we need to undo division of our liters on the right side of the equation. We do this by multiplying both sides by liters over 1. Once we do this, we get liters multiplied by molarity equals the number of moles of sodium chloride. Now let's plug in the numbers we have. So we have 5 as our liter, so 5 times our molarity, which is 1.25. So 5 times 1.25, that's going to give us 6.25 moles of sodium chloride. Now all we have to do is convert those moles to grams. We use our formula mass for this once again. After setting up our formula mass table, we find out that the formula mass for sodium chloride is 58 grams per mole. Now we take our 6.25 moles over 1 and multiply it by 58 grams over 1 mole. We get a total of 362.5 grams of sodium chloride. Okay, so now let's work some molality problems. Let's say I am mixing 100 grams of potassium chloride in water to make a solution that has a mass of 500 grams. Calculate the molality of this problem. So for this problem, we are going to have to convert our potassium chloride to moles and grams of solution to kilograms of solution before we can plug it into our molality formula. To convert our grams of potassium chloride to moles, we're going to use the formula mass of potassium chloride, which is 74 grams per 1 mole. Now we take our 100 grams and put it over 1, then multiply it by 1 mole over 74 grams. This gives us 1.35 moles of potassium chloride. Now we have to convert our grams of solution to kilograms. So we take our 500 grams over 1, and we convert it to kilograms by multiplying it by 1 kilogram over 1,000 grams. This gets us 500 over 1,000, which is 0.5 kilograms. Our last step is to plug both of these into our equation. So we have 1.35 moles of potassium chloride over 0.5 kilograms of solution. Once we divide these out, we get a 2.7 molal solution of sodium chloride. Okay, so that's enough with molarity and molality. Hope this video helped you out, and keep up the good work in the classroom, and see you next time.